Feedback, Pam. I don't know if it's you. Pam.
Yeah.
Yeah.
No, there's feedback, but I've been muted the whole time.
Okay, because it's picking up a Pamela. Maybe there's a different Pamela.
It could
Out
be.
there?
There's not many of us.
There's
There's only one Pam.
there's only one. All right. Well, I don't hear it anymore, so they must have turned it off or it's fixed itself. Do you guys want to review this, or do you want me to? I'm good either way.
I think probably Tien and I can do it.
Yeah,
We'll save your big big intro till later.
Okay, perfect. I'm just gonna step over to the gussy up myself in the mirror.
Mm-hmm.
Okay. It looks like everybody as a group did a really good job of sorting through these. When I'm looking at that first question, I have 12 eggs. Each cake recipe requires 3 eggs. How many cakes can I make? When I'm thinking about quotative, I'm thinking about, am I fair sharing, or am I doling them out like I would deal cards? And in this situation, I'm taking away 3 at a time, so I see that as quotative division.
And the second one, Heather explained, she made these questions a little bit trickier than last time we were doing our multiplication in session 2. This is kind of a rate ratio question. But again, she explained that if you break it down, it is the composite that you don't know. So this is a partitive division question. And for the last one, we had a big debate going on. She threw the fraction in there. And for those folks that were on here ahead of us, we figured out that the fraction actually, when you multiply by a fraction, it makes the answer smaller. And that kind of tripped a few people up. But in the end, we decided if you get rid of the fraction and you put a whole number in there, 2 cups of sugar for each recipe, 3 recipes. How much do I need? It is 6 cups of sugar. So that is a multiplication question.
Mm-hmm. And then I would like, for my reasoning for that is I would look at that as, well, 1 cup times 3. And then, well, so 1 times 3 versus like what is 1/2 of 3 would be the way I would look at that.
Mm-hmm. All right, great job, everyone. So we would like to welcome you to our multiplication and division session 3 with Heather Wark. We'd just like to take some time right now. If you are joining us from the Lambton-Kent District School Board today, which is a traditional territory of the Chippewa, Potawatomi, Odawa, and Delaware nations. And if you are joining us from another location, you are encouraged to recognize the nations whom traditional territory you share today. These nations agreed through their ancestral languages to mutually sharing of the land, obligations and responsibilities to the environment. Today, these responsibilities and obligations extend to all people.
Heather is representing us from Lakehead in Thunder Bay, and they acknowledge that the history that many nations hold in the areas around the campuses, and is committed to the relationship with First Nations, Métis, and Inuit peoples based on the principles of mutual trust, respect, reciprocity, and the collaboration in the spirit of reconciliation.
All right. We'd like to, again, welcome everyone here today, and we thank you for your participation. Tien's got a little picture up there for us all to share.
Oh, it's been a crazy week with all the weather, and just a big thank you that even with all the weather and the crazy things happening in the week, the teaching really is very complex, and we really appreciate you taking time away from your families and coming here and joining us today to help support your students.
Ditto. And we have one last session happening next Tuesday. For those folks, it will be our 3rd and final addition and subtraction. Please join us if you can. We would definitely appreciate it. And this is session 3 with our multiplication and division. Heather has a lot to share today, so we're getting pretty good at keeping things moving here.
So today, in today's session, we are going to be looking at unitizing the distributive property, decomposing a factor, starting with the known fact, and then how the array model connects to these ideas. We are very fortunate to have Heather join us today. She spent the last 10 years working with Alex Lawson as a researcher at Lakehead University. Her master's research formed the basis of the multiplication continua. And two fun facts about Heather. Heather worked as a whitewater rafting guide and spent 5 years in the Naval Reserves. So coming at you from Thunder Bay, Ontario, please welcome Heather Wark.
Thanks, everybody. I think we'll probably just take a second to just make sure that if you're connected here, welcome, but just make sure that your mic is muted because we are getting just a little bit of feedback, and I think it'll be more pleasant for everyone if we mute the microphones out there in the big wide World Wide Web cyber space.
Very comprehensive.
Yeah, thank you. I think it's very technical, very technical. I just wanted to get our brains back in the headspace of where we were. And in the first session, I showed this image, and we were looking at where the continuum of multiplication and division, of student development of multiplication and division, fits into the greater picture of mathematical development. And this figure was created by Pam Harris, and then I interjected our continuum to just kind of give us a sense of where are we looking with our magnifying glass at this moment. We also, in our last session, we looked at how multiplicative problems, particularly equal groups types problems, are constructed. And so we felt pretty comfortable with both pieces of multiplication generally. So we felt pretty comfortable with the numbers we were working with, which is that the number of groups and the composite, we could have those numbers interchanged. We could have 3 groups with 5 in each, or we could have 5 groups with 3 in each. In session 2, we looked at partitive and quotative division, and we realized that for the most part, we were fairly comfortable with the idea of dividing by the number of groups. So we could put the 3 in this location, 15 divided by 3 as the number of groups, and looking for how much each person was going to get, or each group was going to get. But we were a little less comfortable with putting the 3 in the other role, starting with 15 and saying, I'm going to give 3 out to each person. How many people are going to get things? And so this, we talked a fair bit about quotative division and where that was going to, where we were going to talked a fair bit about quotative division and the types of, the reasons why I think it's important for teachers to be, first of all, aware of it, and second of all, to ask quotative division problems. So today, we're going to look at a few different questions today, but this is the one we're going to start with, similar to the ones we looked at previously. So let's pretend that you have 3 packs of gum, and there are 7 pieces in each of the packs. Do you know how much gum you would have all together? And we looked at a similar thing when we talked about, and I first talked about the key idea of unitizing. So unitizing is one of the most important key ideas we've got when we're talking about the development of multiplication and division. And so the initial unitizing idea occurs when we have a student who can tell us that that they know that 1 pack is 7 gum, and that they can hold those 2 ideas at the same time in their head. So here's 1 pack because it's 7 gum, and here's another pack that's 7 gum, and here's another pack that's 7 gum. And they can even use those same counting numbers to actually count up the packs, 1, 2, 3 packs. Whereas up until this point, these counting numbers were reserved for individual objects and not groups of objects. And then in our first session, when we looked at the strategies on the continuum, our students got to the point where they could actually then like add up the gum. So they could say, well, 7, 14, 21, and they could tell us at the end of that 3 packs would be 21 gum. So they've gotten pretty far along the continuum here, and I've noted their progress with this red line. And so we've worked through some of these initial strategies, including maybe skip counting and repeated addition, which we talked about a fair bit in the last session. But this red line really tends to be a pretty big stopping point for many students, in that even when I work with adults, they often haven't actually gotten past this point in their understanding of multiplication and division. They know they can repeatedly add to solve a multiplication problem or a division problem, and that's pretty much it for their understanding. They've kind of switched from this point to maybe using a calculator, and they never looked back. And so when they're asked to do it without a calculator, this is all that they have.
I think that's an important point that you make there, Heather, is that often when we're looking at this continua, is understanding that it is a developmental continuum and that it can extend into adulthood for many people.
A lot of the research on the development of multiplicative thinking has been working with adults, because, you know, those first year university students are so easy for us to get our hands on as researchers. And here it's also really helpful because many of them have not actually developed multiplicative reasoning. And so we can definitely use their we can use what they know about math and follow that back to their elementary schooling, and they really don't necessarily get past that point. I'm just going to talk a little bit here about this analogy that, if you were with us with addition, you've heard it before. So I'm going to go through it pretty quickly, but basically the idea that when students approach a problem, they don't know, necessarily, if it's the first time they've approached this problem, they don't know necessarily how they're going to get to the answer. And so just like if I was walked up to this cornfield, and let's say I had to get to your house, Tien, and you're on the other side your house is on the other side of this cornfield, I can't see your house from here, so I don't really know the best way to walk through here. So I'm just gonna, hopefully the farmer's a kind person. I'm just gonna start trudging down in this corn to try to find my way to your house, and I might, take a fairly long route to get there. But when I do get there, I'll have, achieved my goal of getting to your house. And over a few times, I'm going to make a little pathway through the corn towards Tien's house. And every time I get to this field of corn, if I'm heading to your house, I am probably likely going to step on this pathway, as opposed to getting in on trying to start a new one, because starting a new one is harder work. And this is now a little easier to walk down, and I can see where I'm going. I know where I'm going. I'm confident I'm going to get there. And so I'm maybe more comfortable going down this than I am starting a brand new path, even if this one is longer than what that one would be in the end. And then if this is, say, repeated addition, and we know this is going to get us to the answer, we feel pretty comfortable there. And so as our numbers get bigger, we get more and more comfortable, and we just make that pathway bigger and bigger. And as I was saying in our last session with addition, I've got a colleague up here who talks about the fact that students will get out the sidewalk paver and make this, put it on their rollerblades, and they can actually get pretty efficient and pretty fast at some of these strategies that are, they do get you to the right answer, but they're not particularly sophisticated. So with repeated addition and perhaps skip counting, but certainly with repeated addition, we definitely get in this territory. A lot of junior students kind of get stuck here, and they get pretty comfortable walking along this pathway. And our job is to try to see if we can't get them to take a different one.
I think that's good to note too, Heather, because and that it can change based on the context or the content of the problem, that they could jump from being efficient back to making a new path in the cornfield, and everything starts all over again.
Yeah, it is really tricky once they've gotten it to the point where it feels really efficient for them. That is harder to change than if we can catch them before it feels that comfortable. But, you know, we do the best that we can, you know, and um, hopefully some of the stuff that we're going to be talking about will help us to open up some of those other pathways, and that's where we're going to spend sort of the rest of our time, is looking at this green territory.
Awesome.
So sometimes what happens, and this is certainly true of my adult students, is certainly true for me as well, is that I kind of got to this point and then I went to automatic retrieval for the facts. And so I just memorized the facts here. And then if I was working with bigger numbers, like double digits, then I had, you know, a procedure and a standard algorithm that I learned that I could use. And basically, this whole territory was missing. I had repeated addition. I certainly understood how to do that. I had my facts, mostly automatic, and I had the standard algorithm that I could use. But really, I hadn't picked up or learned most of this territory before that time. And this is actually where the birthplace of multiplicative thinking is. So we can certainly be here, over here, where what's labeled as proficiency here, and not actually have constructed multiplicative reasoning. It looks pretty promising because it's in this proficiency category here on the continuum. But I think what's important for me to keep remembering is that this is a whole picture. You can't just take a snapshot of it. And so actually, without this territory, if students haven't gone through this territory, they actually don't get to proficiency. This diagram, this picture, assumes that the student has traveled through working with the relationship on their way to these things over here on the right. And I know for me as a student, that was not the case. I missed all that middle bit. So
I think that's very good to point out to the people too, Heather. This is what we're doing, fill in the gaps.
Yes, because even if we have those other things, we maybe, depends on the student, but and with their experiences that they've had, but they might be missing things there in the middle.
Yeah.
So we want to go back and make sure that we cover in that territory.
It's a great
So
map
one
of the
way, what's that?
That's a great map of the landscape.
So one of the things that students can demonstrate that they've gotten that they're developing more sophistication in multiplicative thinking is that they can actually show more simultaneity here in thinking about these three components of the problem. So in our image here, what they might be able to do is talk about the fact that 1 pack is 7 gum, 2 packs is 14, and 3 packs is 21. And this, going from 1 to 7, 2 to 14, and 3 and 21, and keeping all of that information close together the way it's laid out here, has increased simultaneity, we call it. Because with unitizing, we're always talking about how close together are they able to think about the components. And here we see them really thinking about them nice and tightly together. And this is the precursor for proportional reasoning down the road. Another thing that they can do, which is different from that, is actually to unitize in a more sophisticated way. And in this way, they might break up the composite and work with those pieces separately because maybe they know something about those pieces. So here's a student who might know that 1 pack would be 5 plus 2 gum if it's got 7 pieces, that they know that they could decompose the 7 into 5 and 2, and then they can use that over the course of the whole 3 packs. So 3 packs would be 3 times 5, and then they'd have to add 3 times 2, and that would actually give them the total amount of gum, which is 21. And this is an illustration of what we call in mathematics the distributive property. So the knowledge that you can break up a factor and add the pieces back together, multiply out those two pieces and then add them back together, is the foundation of the distributive property. And we see that key idea here on the continuum coming in right around the same part as we're talking about, where this phase line shifts into being able to work with the relationship. So that's where we see that distributive property starting to come in and impact how students are able to get in on the mathematics above. So the first strategy that we are going to talk about tonight that we see coming in here is decomposing a factor. And so what a student will do is actually pretty much exactly like what I just showed you with the packs of gum, is they will break up one of the factors and work with a portion of the problem first and then solve the remaining bit of the problem. So in what we just saw, if a student was going to be using decomposing a factor and we were solving the same problem with the 3 packs of gum with the 7 pieces in each package, they might draw out those packs of gum and then use some numbers to help them out. They might know that each pack of gum is 7, but they're going to think about that as a 5 and a 2. And then how they figure out this last bit depends. And if we look back at the image, on the continuum, this is a very long box because there's different layers of sophistication with which they can put these pieces back together. But here, let's just pretend they're at the very beginning. And so what they might do is they might skip count. They might say 5, 10, 15. And they might skip count 2, 4, 6. So they might then add 15 plus 6, which they may have a variety of ways of doing that to achieve the 21. Hopefully they'll be able to take 5 and give it to the 15 and then end up with 21, or just know that one as a fact. Any questions about those ones?
So when students are doing that, Heather, I'm seeing in your examples that they're breaking the group apart or the composite apart. Is that something that students are likely to do, or what are we looking for as teachers when students are initially looking at this strategy?
It's such an interesting question, Tien, and I meant to say off the top that, and I did say it in the first session, but I didn't say it tonight, is that we're continuing to research this area to see what it is that students actually do and what teachers can do to impact it. It is, I think at this point, it's my hypothesis that students would be more likely actually to group groups together than they would be to break up what's inside the composite the way that I showed you. So they might be more likely in our problem to keep the composite together and maybe put a group together and then add something else that remains. I do think that that's more probable in the beginning. Both of them are important. We need to be able to break up either either factor and understand what that would mean, because sometimes it would be more beneficial to be able to think about things this way, and sometimes it'll be more beneficial to think about things this way. So I'm really curious myself to see where the research goes on this front. I think that it is helpful for students to be able to be flexible here about which factor is being broken up.
Okay, so a variety of strategies is always good.
Maybe. I think they will come. They'll come to this one very easily. This one, I think, will require some more support from instruction.
Okay.
Again, I just like drawing it out with you in the camera. Really just helps to make things seem much more easier to understand as an audience. So keep using the camera.
Good to know. Good to know. I don't know if Mary Lynn had a question there, but we're going to keep moving on. So another one that you see, it's really close here, starting with a familiar fact. I actually can sometimes think that these two things can look very similar to each other, but I actually have a video of my daughter doing this one, so I thought that would be a good little change up here. So there's Kale. Oh, I think I maybe didn't share properly. I might have to fix that. There we go. Sorry, everybody. We'll get it back. We'll get it back. Here we go. The go to Michael's, and you're gonna buy little surprise bags that they have there, and those surprise bags cost $5 for each bag, and you want to buy 7 of them. Before tax, how much is that going to cost you? $35. And how did you get 35?
Well, I know that 5 times 5 is 25.
Okay.
And so I added 2 more 5s, which is 10. And it makes 35.
Makes 35. Okay. All right, so there we hear her, amongst all the other noises in my house, like the dogs whining at the door and the dog wandering around. We hear her doing 5 times 5 is 25, and then she's adding 2 more 10s to that. Or sorry, 2 more 5s, which is 10 to that to figure it out. So she's starting with the fact she knows 5 times 5, and she knows she can utilize that. Now, with the question that I asked had $5 being the price of the bag, so $5 is the composite. And so the way that she's grouping those together is by grouping 5 bags together and not breaking up the composite of the 7 the way that the other question is worded. It's a slightly different problem, and it makes it a lot easier. So I just wanted to add this piece in here because once they are working with the numbers and using a pretty sophisticated strategy for that particular problem, like what we saw Kale doing, then one of the things that we would do now is to help her move towards automaticity, that's towards proficiency on those specific facts. Because when we want them to start paving with the sidewalk paver and strapping on the rollerblades is when they have a strategy that's already really sophisticated to find those facts, and then we do want to speed them up. So we want them to start making big pathways through the corn at this point. So how will we do that as teacher? So this is one of the places. I put games in a lot of places, but this would be a specifically selected game where they would be working on automatizing, in this case, 2, 10, and 5 facts. This is a game that I've adapted from one from U Cubed, which is like a product tic-tac-toe. It's basically like bingo or try to make a line. And I have an example that I made so that you could see how it works. But it kind of looks like this. And we can put this game board in the show notes and people can try it out. But basically, each turn, a student can move one of the paper clips. So if this was my turn, I would have to calculate 3 times 2. And then I get to cover 3 times 2 with my counter. And then it would be my partner's turn. And they can move either this clip or they can move this one. So depending on where they want to go, maybe they want to move this clip. And so now they have to calculate 3 times 5 and find where that one is. And so maybe I would put my counter there. And then it would switch turns, and maybe this time they want to move this one to 7 times 5. Because I really want to put a counter here so that I can try to make my line. for example.
I want to move the 7 to the 8.
You want to move this, this is your turn,
Yes.
and you're yellow?
I'm going to be yellow.
And what does that give you?
That will give me 40.
And so then you're going to block my line I was trying to do, though, Tien. Yeah, I'm going to put yours here because I'm in control.
Okay, I didn't see that other 40. Yes. Okay.
You do get to choose,
a whole other element to the game there.
So they can play it collaboratively or they can play it competitively, which is always, in my opinion, a sign of a good game, because then even your kids who don't like competition can enjoy it. Anyway, we can put some copies of that one in the show notes. This one that I've made, because it just has 2, 5, and 10, this is for early facts, really solidifying those so that they become automatic. One of the things that I see in a lot of my adult students is that they skip count their 5s. They don't know their 5 facts. They always skip count. So I find that really interesting. Another thing that teachers can do to support students is to co-construct the array model. And by co-construct, I mean that along with their class, they actually build arrays that have a meaningful context behind them. So I've got 3 different scenarios that I know teachers have used to construct the array model with their students. So the first one is a colleague of mine up here. His name's Jason Wilton. He teaches grade 3. And he has students construct square meters out of paper. And then what he does is he puts a tape outline on the floor, and he taught, because he was thinking about ordering a rug and for the classroom, and so he puts a tape outline and he asks them to calculate how many square meters each of these different tape outlines might be, so that he can figure out, you know, if he can afford the rug that he wants to buy. And so that's how he starts out. And of course, they become very familiar with the square meter, which is very helpful. Then he transitions it to small square stickers on paper diagrams, because he wants to be able to explore some other things that would be maybe too big for the space that he has in his classroom. This is not his classroom. Probably most of us wish it was. It's quite lovely.
That was my first thought.
Yeah,
like,
it's not. No,
like a nice place to teach.
Yeah, it does, but it's just a stock picture. But yeah, he transitions to diagrams on paper, and then they fill it in with these little stickers, which just happen to be exactly a square centimeter, which doesn't hurt either. Another one is from the Guide to Effective Instruction. Tiling a rectangular room or a patio. You might have children actually work with real objects, like real tiles and some real space, like Jason does, so that they can learn to draw their own arrays and fully understand what's inside. So this one comes out of the Guide to Effective Instruction, and where they're tiling a patio. So that's something that I know lots of teachers have tried. Another one, this is the one that I've done myself, is making and selling dog treats. So there's a bunch of pictures here, but the students, these little rubber silicone mats are often used to create these tiny little training size dog treats. And here's a picture of one of my dogs and the treat. And the students, you can cut these mats are made out of silicone, so I cut them into various sizes, and depending on how many treats somebody wants to buy, then they can use a specific size of treat making mat, and figure out how many what the dimensions would be, or certain dimensions are given and they have to figure out how many treats there would be inside. So that's one that I have done, and we'll see evidence of that in a few minutes. Oh, there she is. So why is it so important to really dig into and spend some time constructing these models? the reason is that the mathematics, the multiplicative thinking mathematics, is actually quite challenging, and sometimes students will get tripped up in it. And if they don't have the model to fall back onto, it might not make any sense. When they make an error, they might not be able to self-correct. So here's a video, not very well shot, of my daughter working on some math at the kitchen table. And but I hope you can persevere with the poor video quality, because there's some good things, I think, in this video that are pertinent to our discussion about why a model is so helpful.
How would you figure out 8 times 8?
Right? Think about it as 8 times 10. Is it going to be easier? Because that's 80.
So she wants to use a fact she knows, which is 8 times 10, to help her out.
72.
Okay, how'd you get that?
A lot of things in my head, but this equals 80. Minus 8 equals 72.
And why did you minus 8?
Because I minused. Well, I don't know which one to do, because normally on my last question, which was 6 times 7, I knew that I had to do this one. So I guess I actually round up this one.
She's contemplating there which number she's going to subtract. This is a square problem, 8 times 8, and usually the problems I've given her up to this point haven't always been square problems. So she usually says she subtracts the second number. So if it was 6 times 7, she would subtract 7. So that's what she would subtract. But she doesn't really, that question is uncovering a little bit of hesitation and a little bit of not fully understanding why she's subtracting. And of course, you probably picked up the fact that she just subtracted 1/8, even though she used 8 times 10 to help her solve 8 times 8.
So 72, how many 8s is that then? If you had 8 times 10, and then you took away 1/8.
And I took away 1/8. That's 8 8s.
How many 8s did you calculate?
1.
Cool.
What is it?
Do you remember when we made the dog cookies?
So I went back and questioned her. After stopping the video, I restarted it. I questioned her. And I'm bringing back in the context of making the dog cookies to help her be able to sink the math into something real.
Yeah.
If we were going to use a tray that was 8 by 8, how many cookies would we make?
So she's drawing out that tray here. Sped it up for you guys. I love the pen, but it was a little hard to film around. The camera kept wanting to pick it up.
I love that
Mom,
quill
is another
pens are
way to
just a
think
natural
about
thing in
this
your
8
house.
times 8?
Would that tell you how many cookies there were inside there?
Yeah. It would say 72.
You think it's 72?
Yeah.
And why do you think it's 72?
Because 8 times 8.
And you think that's 72?
Yeah.
Why do you think that's 72?
Because there's 8 here, 8 here, 8, 8, 8. It's 8 8s.
8 8.
And another way to think about that is 8 times 8, which is a question that I just did.
Mm-hmm.
Another way to think about 8 times 8 is 8 times 10.
She finally gave me something I could work with. That fact that she's pulling in 8 times 10, now I've got something I can work with.
10.
Okay. And can you make a dog tray that would be 8 times 10? In case, like, just pretend you were going to make 8 times 10 cookies instead.
there.
Okay.
That has 80 cookies in it.
80 cookies in there. And where, if you were going to use this one to make the 8 times 8, how could you change that tray to make it be 8 times 8?
Cut off that.
Okay.
snip.
And how many cookies are in this piece that you cut off?
That would be 16.
16 cookies?
16 poor cookies going to waste.
Going to waste. And you said, how many did you say were in the whole tray here?
80.
80. So if you cut off 16, how many cookies would you have left?
64.
64. So 8 times 8 is
64.
64 cookies. Nice.
So then I was wrong on the last one.
So she is able to, because she really knows that context of making those cookies, and she even says that she's wasting those poor cookies. She's really thinking about it, and because she understands the array, she can go back and self-correct on the mathematics. She really, I think, understands that she needed to subtract 2 8s. I actually did go back and bring it back to the last question, and she says that she should have subtracted 2 8s and she only subtracted 1.
Was she writing on grid paper, or was that an open or closed array?
Well, it's a good question. It was actually grid paper, but she didn't actually do any counting. So she actually could have been moved to an open array.
Okay.
And I think,
How would you?
there we go. I think I have, for folks who aren't familiar with that, I think there's a slide later about the difference. I think she could do an open array, but she's never worked with one before, as far as I know. So here we see her doing a whole bunch of things inside this working with the relationship. She doesn't have it all squared away. She's still working at trying to figure it out. And so some more work with the array will help her to solidify some of the pieces in here. So 4 things teachers can do to help get students primed for decomposing a factor. We've seen some of them already, but I thought we could wrap up with looking at them again. So number 1, support students to decompose and work with numbers flexibly. This is an addition context here. Students can't decompose in multiplication if they can't do it in addition first. So they have to be able to decompose those numbers flexibly. This is a diagram of an overshoot and return, which is basically, it's definitely related to what she's doing, because she's doing a times 10 to figure out a times 8. So she has to cut some stuff off at the end. And so that type of thinking is really helpful moving forward. Co-construct and model on the array. So really investing the time so the students have a model, a visual model. Math is visual for everyone. And so having these visual models will be essential for them to be able to really understand the math that's going on. You could see with Kale, she got lost in just using the number symbols. And as soon as it was on the array, she was able to make sense of what was going on in the math.
A question there, Heather.
Yeah.
When students are building those arrays, often what they'll do is they'll build a side and the other side. Do they need to build the whole array? Is that something we need to see?
Are you saying, Tien, that they would just do like
The length and the width.
3 times 7 like that?
Right.
And then what do they do?
And then they will maybe use repeated addition or a multiplication fact to solve from there.
So they might, I
So
guess
they might-
for me it would depend on the student. So
Okay.
if some of them will need it and some of them might not. Are you asking me if they just need to close this up?
If they're actually building that array with the concrete model, do they need to
Oh.
build the complete model?
So you're saying they're using something like a tile.
Right, 3
And
tiles.
they're I didn't use
Right.
my tiles, but I just guesstimated. I didn't do too badly, actually.
Nice.
Yeah, pretty good. And so then they would put 7
7
along
across
the
the
top,
top. Yes.
and then they wouldn't fill it in. Yeah, I don't think they need to build the whole thing. They can
Okay.
probably use just that to visualize, and it's helpful if they can visualize it. We want to encourage that.
Okay.
So even if they only just did one of the sides and then we're able to kind of iterate it.
Right.
It comes to a point, I know when I was showing you the stuff that Jason was doing with his tile stickers that he was using with his kids, so very similar. He got to the point where he told them he was running out of stickers and he didn't have enough for them to like fill the whole thing in, so they were going to have to figure it out, because we do want them to learn to both draw the inside of the array and then later just to visualize and imagine what it would be like.
Okay.
All right. As I said earlier, we need to help students to automatize those early facts. Remember, these are 4 things teachers can do to help students be able to decompose a factor. And in order to have another fact to lean on, they need to know those ones. So we saw here, Kale knows very clearly 8 times 10, and she wants to use that. And she also demonstrated that she knows 8 times 2 in the video with when she gets to drawing the array. She doesn't have to really figure that out. She knows that there's going to be 16 that she's going to cut off. So she knows those 2 facts, and that helps her get be able to use some more sophisticated mathematics. So there's that game. There's so many other ones, but that's just one. And then number 4 is using some context and images with number choice and putting them in a sequence together that might support them to construct the distributive properties. So here's a little picture that you might show. So we've got 5 bags, each $5, and they could figure out how much that was going to cost. And then if you show this image, they will likely consider the option of just adding 2 more bags to figure out 7 times 5. So using those 2 in sequence with each other can help them to use the distributive property without knowing it, which means that we can then talk about that, that 7 times would be the same as 5 times plus 2 times. And is that true? So I think that's all that I have, and we did not too badly sticking tight to our timeline, but maybe there's some questions that came in the chat while I was motoring through.
We're checking the chat right now. I got to say, Heather, this was awesome, very informative. I think the camera helps folks out a lot, being able to understand, you can visually see what you're doing and what you're talking about. I think the tips at the end, again, are the goal that everybody's waiting to see, is how they can use it for their own students. And we'll check the chat for questions, but I don't see any. So we'll just like to wrap it up, folks. And again, if you have any questions, here are some places you can go to look for some answers. We have one more session coming up, and that is next Tuesday. And it is the final the final addition and subtraction one.
Just a reminder that all of these sessions are archived on the blog. So if you go to lkelmpro.blogspot.com, all of the previous sessions and our future sessions will be archived there for future reference. So if you're joining us after the fact, we welcome and thank you for coming in and checking it out. If you've got a few moments and you're willing to stick around, we would really appreciate and value your feedback. We're really looking at how we can improve and grow as facilitators. So any help that you guys could provide us would be really, really helpful for us.